A chemical indicator changes color in the presence of acid or base, and chemists can use these color changes to find out if a solution is acidic or basic. There are also combinations of chemical indicators, and they're called universal indicators. There are a series of different indicators, so they'll go through a range of color changes. Now here we have a sample of pH indicating paper, which contains a universal indicator, and we will put just a little bit of an ammonium cleaning solution on it, and we see that the dye changed to a blue, the pH about 12 or 13, and then we can take a little bit of acetic acid, vinegar, commonly found around the home, and you notice that it changes to red, which is a pH of about 2. So acetic acid, we know from this indicator paper, has pH of 2. Bill, we talked about chemicals, but can we also think of some examples of chemical indicators in the world around us?
Certainly, Joyce. Our audience may not be aware, but items such as beets, red cabbage, radishes, and the spice turmeric and alcohol are all very good acid-base indicators. In fact, red cabbage functions very much like a universal indicator because it goes through a whole series of color changes depending on the pH of the solution that it's exposed to.
pH refers to the hydrogen ion concentration of a solution.
I think one of the easiest ways to look at pH changes is to consider the fact that not all water exists as H2O, as water molecules, but some of the water breaks down into hydrogen ions and hydroxyl ions. And we'll use these film canisters to designate this, where the top will be a hydrogen ion and where the bottom will be a hydroxyl ion. Now, if we have a solution where we have an excess of tops or an excess of hydrogen ions, when these combine together to form water molecules, this extra hydrogen ion that we have here results in a condition of high pH because we have more hydrogen ions than we have hydroxyl ions, and so we have a pH in an acidic range, or between 0 and 7. On the other hand, when we have a circumstance where we have more bottoms than we have tops, then when the ions combine, we have this excess of hydroxyl ions or a deficiency of hydrogen ions. This means that the solution is basic, or the pH has a value from 7 on up to 14.
Pure water is neutral and will have a pH of about 7.
Most foods are acidic, and most cleaning solutions are basic. In fact, shampoo is basic, and there's a very good reason why it is. The principal reason is it needs to be basic to remove the oil and dirt from your hair. But what happens is, if you leave this basic liquid on your hair, it causes dullness, and it also causes the ends to split, because basic conditions tend to break the hair down. That's why your drain cleaners that you pour down the drain to remove buildup of hair, they're all basic. So what you do to help your hair after you've shampooed it is you use an acid rinse or a neutralizer to go ahead and get the pH slightly on the acidic side, maybe like a pH of 4 or 5, because at that point the hair is the strongest